Hi everyone. Today we'll be discussing about the chapter known as theory of column. It is a part of SOAM. Yeah, and frequent questions are being asked by this chapter. So let's start. So before coming to column, we'll be knowing what is strut. So what is struts? It is a structural member which helps in load distribution, and basically if we talk about its position, it is basically inclined, right? So it is a structural member. Okay, it is used for support, and it is inclined. If we talk about how it is look like, so this is a crane. This is a crane. Let us take an example of crane. So the thing is, this is all structure, right? And we provide a strut here to support, and as we can see that this is at an angle, some angle, right? This is at an angle, some, like, this is known as strut. Now after that, what we'll do, we'll talk about columns. So what is column? So columns are structural member. When we uh, make the strut vertical, not in a inclined position, it is known as columns, right? So this is a column, or we can say pillar. Pillar are columns, right? So it is a member, structural member. It is a structural member, and it is vertical, right? And it consists of compressive force only, only compressive force, that is negative force. That means this direction, right? After that, when we know about what is the concept, how columns, what we'll study here. So basically we'll be studying about columns failure. So there are two types of column failure. First one is buckling. So what do you mean by buckling? So buckling is nothing but sudden bending. At this point failure automatically happen, right? So this is buckling. So buckling happens in long, long columns. Suppose this of L length, and after buckling it becomes like this. This is buckling. So this is the first type of uh, that is a failure, right? So here what we will do, we'll be calculating area moment of inertia. Like if we saw a structure and it is a top view, this is like D and this is B, and this is all about the x, no sorry, y axis. If we talk about this is the member, right? And large view. So Iyy equals to what will be there? This is the formula, b d b cube by 2. This is the area moment of inertia, right? If the area moment of inertia is greater in y than x axis, then it will be known as slender. Slender means easy to buckle. Okay. After that, we'll be coming to this part of second type of failure, that is uh, crushing. At this point, what is suddenly crushing is happening? We come to know about many news in YouTube, वगैरह, right? So we see that suddenly crushed. So at this time, failure of happened, right? Failure actually happened. Failure had already happened, right? and it is used to see in short columns. And after these two failure, what we learn methods of preventing failure. Mm, Gate point of view, only one method is important. That is one and only Euler's Euler theory of long call. It is important in gate. So it is used for only long call, and it is used for only long columns, and it prevents from buckling. Uh, like for preventing, what we require is area movement, that is a k square. So what is k? Here k is, let me tell you that k is radius of gyration. Sorry, radius of gyration, and a is area. Yeah. After that, how do you come to know that a is area and k is? How do we figure out? So let me tell you. If we take IYY of rectangle of rectangular section, that is like this. It is B, it is D. So I have taken area moment at y-axis. So what will be the IYY? It is dB cubed by 12. And if we compare with IYY a k square, so as you can see, dB is equals to area, as it is a rectangular section, and k square equals to b square by 12, like this. So this is nothing but k square, and this is nothing but area. So after implementation, k square equals to b square by 12, square square root of b square by 12, k is equals to b by 2 root 3. This is nothing but radius of gyration. Okay. After that, we'll be coming to a point that very important point actually. It is Euler's critical loading. This implies that after equating the critical load, we will come to know minimum effective length and many more. So I'm directly writing the formula like PCR. That is the equation pi square into EI upon LE square. So what is this? So pi, this is not nothing but flexural rigidity, and this is nothing but effective length, the length at which load is acting, right? That is effective length. Now after that, if EI is greater, flexural rigidity is greater, then rigid, because P critical will be greater. And if EI is smaller, then PCR will be smaller, that is less rigid. Okay, after that, what will be knowing that there are four types of buckling loads. First is both and hinge. Second is one and fixed, another free. Third is both and fixed, and fourth is one fixed and other hinged. So what you have to do, you have to only uh, replace LE by L given. So what will be L given? So here in this case, LE is equals to L. Here in this case, LE is equals to 2L because it is hard to buckle the fixed ends. And LE is equals to L by 2 in fixed because it is hard to buckle in fixed. And here L is equals to L by root. So this is all about the chapter of theory of columns. That's it. Thank you.